Hello everyone, welcome back to our discussion on multiple alleles. So in the last sessions we discussed about the peculiarities of RBC, its structure, which was followed by how what are the antigens and antibodies which are present in the blood, which is related to the human blood group. So we are continuing our discussion on the ABO blood group in man. So the antigens and the antibodies that we discussed, they're crucial when it comes to blood transfusions because as we said, if we are mixing the bloods which are not compatible, that may result in hemolysis. And this hemolysis is just the rupture of the RBC because of the antibody. So the antibodies tend to clump the RBCs together, and the immune cells they destroy the RBC, which result in hemolysis. After hemolysis, the hemoglobin and the broken RBC they may block the capillaries, and the hemoglobin they may reach the kidney, and that might result in kidney failure, etc. So these are the complications that might occur when there is a transfusion of incompatible blood. So incompatible blood transfusion. Antibodies in the recipient plasma bind to the donor's RBC, which causes agglutination or clumping of RBC. So this agglutination is an antigen antibody response in which the RBCs become cross-linked with one another. So we discussed in the first session that never RBC clump together because of the presence of the highly negatively charged sialic acid on their membrane. So when this happens, they become cross-linked, and they cross-link to each other, and that will result in the destruction of the RBC, which is called as hemolysis. So we'll discuss a particular case when we are mixing in incompatible blood. What are the possible consequences if you mix incompatible blood? So in this case, we are going to try if we are going to mix the type A blood with type B blood. The recipient blood, which is type A, contains A antigens on their RBC and A antibodies in their antibodies in their plasma. And the donor's blood. So we are going to the recipient is A blood group, and we are going to give him B blood group. So the donor's blood is type B, where he has type B antigens and type A antibodies in his plasma. So in this situation, two things can happen. The first thing is that the B antibodies in the recipient's plasma, because he is having A blood group, so there is B antibodies in his plasma, can bind to the B antigen. So B blood group is being transfused into the particular person. As a result, when the blood is being transfused, the transfused donor blood is having B antigens. Because the recipient is having the B antibodies, all the B RBCs or the antigens with B RBCs will be destroyed by hemolysis by the recipient's antibody. So that is the first thing, or the first and the major thing that will happen. So the first is the B antibodies in the recipient plasma will bind to the B antigens on the donor's erythrocytes, causing agglutination and hemolysis. The second is a minor thing that can happen. That is, the A antibodies in the donor's plasma can bind to the A antigens on the recipient blood cells. So this is a very minor reaction, or this is a less possible reaction, which might not happen. The reason is that the donor's A antibodies become so diluted. So donors means it is a B blood group with A antibodies. The recipient is having A blood group, and his RBCs are having A antigen, but the amount of blood transfused is very small compared to the amount of blood in the recipient's body. So in such cases, what happens is the donor's blood, the antibodies in the donor's blood become so diluted that the recipient plasma, that they do not cause sufficient agglutination and hemolysis of the recipient RBC. compared to the if it was antigens in the as in the first case, hemolysis will happen, and that is for sure and definite. But in the second reaction, which is less likely to happen, the reason is that when you are adding antibodies in the donor's RBC, or the donor's blood, what happens is that it becomes so diluted. The amount of antibodies will be so less compared to that of the recipient's blood. And as a result, such an agglutination or hemolysis, that is agglutination of the recipient's RBC, is like less likely to happen. But the hemolysis of the donor's RBC is likely to happen, and that might result in complication when you are mixing incompatible blood. And to avoid such complications, we use blood grouping, and we transfuse only compatible blood. Transfusion in nowadays, it is not only linked with compatible blood, it is also linked to other factors, other risk factors. The one we'll be discussing in this particular session, that is the RH blood groups, followed by the other two major criteria that is followed during transfusion is uh, HIV test, and also hepatitis test. So such criteria is also monitored before blood transfusion. So people with type AB blood group, they do not have antigens, sorry, they do not have antibodies in their blood plasma, and hence they are sometimes called as universal recipients. They do not have antibodies because they are having both the antigens, and as they do not have any antibodies in their blood, what happens is they can receive any type of blood, any blood. When you observe this particular case, that is people with type AB blood group, if you are AB blood group, there is no antibodies in your blood plasma. So what happens is, if you take A blood group, there is no issue that, because the donor's blood is having A antigens, and as there is no antibodies for the recipients, hemolysis is less likely to happen. But the second reaction, as we discussed in the previous slide, the second reaction is less likely to happen. Second reaction is that the donor's blood, if you are giving A blood group to an AB person, the A blood group is having anti-B, and theoretically there are chances that this anti-B can attack the B antigens on the AB blood group RBC, but that is less likely to happen because the amount of B antibodies in the donor's blood is or that will be diluted when it is being transfused. That is why they are called as universal recipient. Even though they are called as universal recipients, this is theoretical. So they are this can be called as only theoretical universal recipients. Theoretically, they can receive blood from the donors of all four blood types, and as they have no antibodies to attack the antigens on the RBCs. So in this case, and with regard to the universal donor, I have uh, put it as theoretically they are called as universal recipients, and theoretically they are called as universal donors because, as I mentioned earlier, it is not only this particular compatibility or this particular criteria that is being followed for blood transfusion. There are other major criteria also to be followed during blood transfusion. So that's why we call this particular thing, even though you call them universal donor, universal recipient, etc., that is just in theory. But in practical purposes, we also go for other major criteria during transfusion. So people with O blood have neither A or B antigens on their RBC, and are sometimes called as universal donors. Because there is no antigens in their blood, they are called as universal donors. And the reason is the same as suggested before. they have only the antibodies, and that particular antibodies, when that is being transfused into a recipient's blood, whatever the blood might be, that becomes the antibodies become so diluted so that they do not attack the recipient RBC. So that is why theoretically they can donate blood to all four ABO types, and type O persons require blood may receive only from type O. They can receive blood only from type O person, and hence type O is usually theoretically they can be called as universal donors, and AB blood group individuals can be theoretically called as universal recipients. So this is a chart or a table which shows the summary of the ABO blood group interactions. So you can see here the antigens in the case of A blood group it is A, and the gluten or the antibody is anti-B, and the compatible blood groups are A is compatible, O being a universal donor is also compatible. The incompatible blood for an A blood group person is B as well as AB. And coming to the B blood group person, he is having the antigen or the agglutinogen, which is B. The antibody is anti-A. Compatible blood is B and O. And incompatible blood types are A and AB. Coming to AB, which is a universal recipient, they can they have both antigens A and B. There is no antibody in their blood, and they can their blood is compatible with A, B, AB, and O, and incompatible is nothing. That's why they are called as universal recipients. They can receive blood from all the four blood types. Coming to O, they have neither A or B antigens. They have both the antibodies. The only compatible is O. They cannot receive from blood from the other three blood types, that is A, B, and AB. So with this, we are coming to the end of the particular antigens, or the discussion on the antigens and the antibodies and the compatibility of the blood in the ABO blood group system. And now we are going to discuss about the inheritance of the blood group allele. How this blood group alleles are inherited. So in the previous sessions, we confined our discussion on how or what are the uh, major factors that are responsible for classifying or categorizing the blood group, and we discussed about the ABO system, which was based on the A and B antigens, and on the basis we have four different types of blood group, which is A, B, AB, and O. And we also discussed how they become compatible and how the blood become incompatible, and what are the factors that is affecting its compatibility, etc. So in the next session, we'll be discussing about the inheritance of the blood group alleles. Thanks for hearing.